the act or the result of a quantitative comparison between an unknown quantity and a predefined standard. The unknown quantity which we want to measure is called the measurand, and the predefined standard is having the value which we already know. Okay, so the unknown quantity and an unknown quantity, they are compared, and the result of that comparison is called the measurement. Now there are various methods of measurement available, and these methods of measurement, they are classified into different categories. So that is the definition of the measurement. So let's start with the methods of measurement. If we broadly classify the methods of measurement, then there are two types of methods. First is the direct methods, and second is indirect methods. So the difference between the direct methods and indirect methods is that in direct methods, the unknown quantity, that is the measurand which we want to measure, that is measured directly. No comparison is made. Directly the instrument is connected to the unknown quantity and the measurement is done. So direct measurement is done in the direct methods, and in indirect methods we will do some type of comparison. We are not directly measuring the unknown quantity, we will measure some other quantity, and with the help of some formulas we are going to measure the unknown quantity. So let's study these methods in detail. First we will start with the direct methods. So in direct measurement methods, the unknown quantity is directly measured. So example of direct methods are like measurement of current using the ammeter, measurement of voltage using the voltmeter, and measurement of resistance using the ohm meter, and measurement of power using the wattmeter. So we are directly measuring the unknown quantity by using the measuring instrument, and the measuring instrument will give us directly the reading of the measurand. Like ammeter, it will directly indicate the value of the current flowing in the circuit. The voltmeter, it will directly give us the value of the voltage across the conductor. So the measuring instrument, it is directly giving us the readings of the unknown quantity. So these type of methods are called the direct measurement methods. Okay, so this was the direct measurement methods. Next, these direct measurement methods, they are also further classified into two types. One is the deflection methods and second is the comparison methods. In the examples, you see that we are taking the example of ammeter, voltmeter, ohm meter and the wattmeter. So when we see these instruments, we have a pointer in it. So the result of the measurement, like the current, voltage, they are indicated by the deflection of the pointer. Suppose we are measuring the current. So this is our conductor. If we are measuring the current, we will connect the ammeter in series with it, and if we are measuring the voltage, we will connect it in parallel across the conductor. Okay, so whatever voltage is there across this conductor, that will be indicated by the deflection of the pointer across a scale. Okay, so these types of methods will be called the deflection methods, where a pointer is deflected over a calibrated scale, and by reading the pointer we are going to get the result of the measurement. Okay, so these are the type of direct deflection methods, whereas there are some methods and we will do the comparison. Okay, like if we want to measure the if we want to measure the EMF, okay, of a cell, and then we are going to compare it with the EMF of a cell, of a standard cell whose EMF we already know, like we will do in the case of potentiometer. In potentiometer, we are measuring the EMF of a standard cell, of an unknown cell. Here we are having a cell whose EMF is unknown. Now we are going to measure this unknown EMF by comparing it with a standard cell whose EMF is known to us. So here the unknown quantity, it is measured by comparing it with a known quantity. So that is a type of comparison methods. So these type are the deflection methods, where the pointer is deflected, and second type of direct methods are the comparison methods. Okay, so these are the two types of direct measurement methods. Let us write the definitions of these deflection and comparison methods. So the definition of deflection methods is these are the methods in which the value of the unknown quantity is measured by the help of a measuring instrument, and this measuring instrument will have a calibrated scale. Calibrated scale means the sections or the points on that scale, they are predefined, they are standard. Okay, so we are having a calibrated scale which indicates the quantity under measurement directly. So in this case, we will have the scale which will have the divisions, and these divisions are already calibrated. And then we have a pointer, and whenever this measuring instrument is connected in the circuit, then it will deflect the pointer on this calibrated scale, indicating the value of the measure of the unknown quantity. So directly the value is indicated. It will start from, suppose, like 0 to 10. It will have various divisions, so we can directly read the value of the measurement from this scale. Okay, now here the pointer is deflected, so that is why it is called the deflection methods. Okay, the other type we studied were the comparison methods. So comparison methods, in them we have the value of the unknown quantity. It is determined by the comparison which is done between the standard quantity and the unknown quantity. So whenever, suppose example is like when we are measuring the unknown EMF of a cell by comparing it with a known EMF of a standard cell. Okay, so that is called that is a type of comparison methods. Now, these are the two types of the direct methods, like deflection methods and comparison methods. Now, these comparison methods, they are also of two types: null comparison methods and differential comparison methods. In null comparison method, suppose we are measuring a quantity by comparing it with a standard quantity, and this measurement is done by nullifying the effect of the unknown quantity. Suppose take an example, if we are measuring the resistances, okay, by using a Wheatstone bridge. So what do we in a Wheatstone bridge? We have the four arms of the Wheatstone bridge in which we connect the resistances. In one arm we have the unknown resistance, and in the three other arms we have the known resistances. So we say that the bridge, the Wheatstone bridge, will be balanced, means no current is passing, or the galvanometer which is connected between the two arms, it will show a null deflection when the four resistances, the ratio of the four resistances is equal. Like here we are having the resistance, here also we are having the resistance. So these are the four arms of the Wheatstone bridge in which in between we connect the galvanometer, and here we have the battery connected. This is the unknown resistance P, Q, R and S, and we say that the bridge will be balanced, means the galvanometer will show the null deflection. No current will pass through this arm when the ratio of the resistances is equal. So P by Q is equals to R by S. So this unknown resistance is measured by nullifying the counter effect, means we are having a null deflection in it, and we are measuring this value by comparing it with the other three known quantities. So that is a type of null comparison methods. Other are the differential methods in which we find out the difference between the quantities. So if we write the definition of the null comparison methods or null methods, okay, so in null methods, the action of the unknown quantity upon the instrument, it is reduced to zero by the counter action of a known quantity of the same kind. Like another example, when we are measuring the weight by the balancing, by weight, okay, so here in the balancing, on one side we have the unknown weight, and on other side we have the known weight, and here in between we will have a pointer. Okay, so when this pointer will be on means on a straight line, that means the known weight and the unknown weight, they are equal to each other. So here the action of the unknown quantity upon the instrument, it is reduced due to the counter action of another known quantity which is of the same kind. Here we are having weight on both the sides, so when the unknown weight is equal to the known weight, then the pointer will be straight, it will not be deflected on any side, either on left or on the right side, side it will not be deflected. So that is the type of null methods. So we have studied that the methods of measurement, it is divided into direct methods and indirect methods. Direct methods, they are further classified into deflection methods and comparison methods, and comparison methods, they are further classified into null methods and differential methods. Now come to the indirect methods of measurements. So indirect methods, they are used in those places where the direct measurement of the unknown quantity is not possible. So indirectly we are doing the measurement. We are not going to directly measure the unknown quantity. We will measure some other quantity, and that quantity will have some empirical relationship or some formula is related between the two quantities. So indirectly we are measuring the quantity. So in the indirect methods, the unknown quantity, it is determined by measuring the functionally related quantity and then calculating the desired quantity rather than measuring it directly. Let us take an example. Suppose we want to measure the resistance of a conductor. Okay, this is the conductor, and we want to measure the resistance. So directly we are not measuring the resistance. What we calculate, first we will measure the current across this conductor with the help of an ammeter. Ammeter is connected in series with the conductor, and then we will measure the voltage across this conductor with the help of a voltmeter. Voltmeter is connected in parallel, and then we have a battery connected across this conductor. So we want to find out the resistance of this conductor. Okay, so what we will get from the voltmeter, we will get the voltage readings, and from the ammeter we will get the current readings. So V and I we can calculate. Now we know that through the Ohm's law, V is equals to IR, or we can say that the resistance R is equals to V divided by I. So voltage readings we have the current readings. So we will first form a table in which we have the voltmeter readings and the ammeter readings. Then we will divide the voltage and the current, and then we will get the resistance readings, and then we will calculate the average of those readings. So that will be the resistance of the conductor. So what we are doing, we are measuring the resistance not directly. We are measuring the voltage and current which are functionally or which are related to the resistance through a formula called the Ohm's law. So in these types of methods are called the indirect methods, where the measurement, the unknown quantity, it is not directly measured, but the quantities which are functionally related to them by some empirical formula, they are calculated, and then by using that formula we calculate the unknown quantity. So these are the indirect methods of measurement. Okay, so in this video we studied the various types of methods of measurement. We studied that how they are classified. If we form a chart of it, so methods of measurement, they are classified into two types, direct and indirect. Direct methods we studied that they are further classified into deflection methods and comparison methods. And comparison methods, they are further classified into null methods and differential methods. So these are the various types of methods of measurement about which we studied in this video. So I hope that this topic is clear to you. Thank you.